Let's begin by reviewing our basic definition of a vector. Remember that a vector is just a quantity that has direction as well as magnitude. Some examples are velocity, displacement, and most importantly for our unit, forces. To represent a vector quantity, we show it as an arrow on our paper. Let's look at the example of a displacement vector. Okay, so let's say that I was going to walk 15 meters to the right. The way that I would show that as a vector, okay, is to draw my arrow to the right a specific length. Now this specific length I'm picking to be 15 meters. Let's say I'm not going to walk 15 meters, I'm going to walk 30 meters instead. To show that difference as a vector, my vector would be twice as long. So the length of the arrow represents the magnitude part of the number. The direction of the arrow shows the direction of that vector quantity as well. What's special about vectors is that we can break them into components. From physicsclassroom.com, here's our definition of basically what a vector component is. Any vector that's directed in 2 dimensions can be thought of as having an influence in 2 different directions. In other words, it has 2 different parts, and each of those parts is what we call a vector component. So if you take a look at the 2 examples given, for this very first one, a northwest vector could be thought of as having a northward influence as well as a westward influence. This northward and this westward part are what we would consider the components. An upward and rightward vector has an upward component and a rightward component. Those influences are what we consider the components of a vector. So why bother with vectors in the first place? To give you a preview of kind of where we're going, imagine that we had a tug of war taking place. And this side pulls with 7 pounds of force, and this side pulls with 10 pounds of force. How would you figure out what that net force is going to be? Well, just like you would in a math class, you would take your rightward number and subtract that from your leftward number. And we would get an answer of 3 pounds going to the right. So if this were a tug of war, we know that everything would move to that rightward direction. But what if instead of it being in a nice straight line, we actually had 3 teams pulling on a rope? How do we know who is going to win? Well, it's not as easy as just adding 7 and 10 and 3 together. We have to approach it from a vector standpoint. So that's where we deal with what we call vector components. Okay, this website from Zonaland is going to give us an example of different ways that we can draw vector components. Okay, so here's an example of a black vector as my actual vector. The green vector represents that northward influence. The pink vector represents that rightward influence. So notice again how we're just taking that overall vector and breaking it into different parts. This is one way that we can show the components. Another way looks like this. Notice how all we did was we moved that green arrow over to the right. I could also show it this way. I could have shown my upward influence first or my rightward influence. Basically, it doesn't matter which way you actually draw it, it's just how you're showing the direction of those influences. So let's start out and just draw a vector. If I want to show its components, I'm going to show that rightward influence as well as that upward influence. Okay. Hopefully you're noticing that we make a nice right triangle. Again, this would be called our x component. This would be called our y component. Now that I have a nice neat triangle, it's useful to know what the values for this x and y component is. Since it does make a right triangle, we can use our trigonometric functions. Okay, so let's start out with an example. What I'd like you to do is pull out your calculators and make sure you're set to degree mode. And please work along with me as I do a few examples for you. Okay, so let's start out and let's say that we've got a velocity vector. And that velocity vector is equal to 7 meters per second directed at a 15-degree angle. Okay, so just like before, I want to break it into an x component and also a y component. The x component is what's directed along the horizontal axis. The y component is what's directed on that vertical axis. Okay, so let's start out and we want to find our velocity in the x direction. we need to think about where that component is located relative to the angle that's given. This x component is oriented as adjacent to that 15 degrees. So if I come over and look, I'm going to use the cosine function. So when I set this up, the cosine of our angle is going to be this x component of our velocity over the hypotenuse, which is just our plane of velocity. Okay, if I want to put numbers in here, so I'm going to put in cosine of 15 is my velocity in the x direction divided by 7. To rearrange this equation, the way you type it in your calculator is do 7 times the cosine of 15. When you plug that into your calculator, you should get an answer of 6.8 meters per second. I want to do the exact same thing for my velocity in the y direction. This time, if I look at where my y component is at, it's actually opposite that 15 degrees. So then that means I'm going to use my sine function. So sine of my angle is my opposite side, or my y component, over my velocity. Putting in the numbers that we've got, sine of 15 is Vy over 7. Just like we did before, multiply both sides by 7 and get your answer. Hopefully you're getting the same thing that I am, and what that answer is 1.8 meters per second. Okay, let's try one more example together. Okay, I'm going to draw a vector that represents 316 newtons of force directed at a 35-degree angle. Again, just like we did before, split that force into x and y components. To find my force in the x direction, look at where it's at relative to the angle that's given. My x component happens to be adjacent again, so I'm going to use the cosine function. Cosine of my angle is my adjacent side over my hypotenuse. So I'm going to take 316 times the cosine of 35 to figure out that force in that horizontal direction. When you type that into your calculator, you should get 259 newtons. Doing the same thing for my y component, this time my y component is opposite that angle, so I'm going to use my sine function. So sine of 35 is my opposite side over my hypotenuse. Type that in your calculator, you get 181 newtons of force. Being able to solve for the components of a vector is really important when we start talking about adding vectors together. Okay, just like I mentioned before, if we have vectors acting in all kinds of different directions, we need to have a way to find what that overall or what that net force is acting on a point. We'll learn how to do that in our next video.